Hey everyone, we're Adam and Grace, and we are so proud to be your educators from School on X.
We have a question for you today. A bit of a puzzle, really.
Yeah, what do a can of soda, a deep-sea diver, and a high-altitude climber all have in common?
It sounds completely random, right? But the answer connects all three, and it's one of the most powerful ideas in all of chemistry. Let's get into it.
Okay, so let's start there. With this puzzle, it connects these incredibly different worlds, things you'd never ever think are related. And honestly, finding these hidden connections is what makes chemistry so amazing.
So really think about it for a second. A fizzy drink, someone exploring the deepest parts of the ocean, someone on top of a mountain. What could the link possibly be? It seems impossible, but by the end of our little chat today, you're going to see how they're all connected by one beautiful fundamental idea. So Grace, where do we even begin to unravel this?
We start right here, Adam, with this. Now, I know what you're thinking. It looks like a boring old textbook definition. But trust me, this is the key that unlocks everything. A homogeneous mixture. All that means is that it's perfectly uniformly blended. You can't see the different parts. And once you start looking, you realize solutions are everywhere. The air we breathe is a solution of gases. The oceans are solutions. Our blood is a solution. It is the most basic way things mix in our universe.
So, let's take that big idea and connect it back to our puzzle, starting with that can of soda. Everybody knows that sound, right? You crack open a can and you get that satisfying psst, that sharp hiss. That is our very first clue, and it's all about pressure. That hiss is literally a scientific law playing out in your hands. To get all that fizz, all that carbon dioxide into the drink, manufacturers seal the can under incredibly high pressure. They are essentially forcing that gas to dissolve into the liquid. So Grace, break it down for us. On a molecular level, how does just squeezing a gas make it dissolve? Oh, it's because of this beautiful, elegant rule called Henry's Law. And all it really says is that the more pressure you put on a gas, the more of it will dissolve in a liquid. That's it. Think of it like trying to pack clothes into a suitcase. The harder you press down on the lid, which is the pressure, the more clothes you can cram inside, which is the dissolved gas. The formula here, P equals KH times X, just puts that idea into math. P is the pressure, X is how much gas dissolves, and that KH, well, that's a very special number. So that special number, KH, is what we're looking at here. And what's so cool is that every gas has its own unique KH value. It's like a chemical personality trait. But here's the catch. A higher KH value actually means lower solubility. It means the gas is more stubborn. It's less willing to dissolve. So if you look here, helium has a crazy high KH value. It really resists dissolving in water, compared to, say, oxygen, which has a much lower KH.